Network address translation. Network address translation is also considered as one of the security feature. Why? Is it not a process consuming feature? Of course, this is the one which is going to consume the CPU very high. But people see this as a security feature. Actually, I really avoid NATing. What is NATing? Why do I avoid NATing? We'll see that. And why some people think this is one of the security feature. That also we will discuss. And then we'll get into the types of NAT. Network address translation means you change the important item that is seen in network layer. What do you see in network layer as most important? In OSI network layer, what do you see as most important? Answer.
IP addresses.
IP address. The source or the destination IP address. Now, network address translation. You change that original source or the destination to some other IP address. Network address translation. Address is the important thing in network layer, and you translate it. Listen, you're not just translating one packet. You translate every packet before they go out. You translate. See, you are listening to someone. If every now and then, if he speaks in Telugu, Vinandi, Nenu, Singapore Valley, that's okay. You will understand. You will little bit manage. Find he's saying something about Singapore. But if he keeps talking in Telugu for an hour, which you don't know, what you will get? Nothing. You'll really struggle a lot to get the content, but you may not be happy to sit for hours when someone is speaking in some other language which you don't understand. So the reason is you don't understand. You try to translate every word he speaks. You thought he will speak in English, and you came to the class and he started speaking in Telugu. So if someone speaks in the language that you like, you don't have any problem. You can keep paying attention because you don't need to put more pressure in understanding. But when someone speaks in a language which you may not know completely or which you may know a little bit, then it will consume a lot of your brain. For every word he speaks, you need to translate and understand. Sometimes if he speaks too fast, you will miss a lot of things. See, translation is not good. Original is good. because the CPU utilization is going to be very high. Because as the packet goes out, you open the packet, change the IP address itself for every single packet. Not only that, when the reply comes, you need to keep track of those changes that you did earlier while sending. Now you need to reverse that process. Put back the original address when the reply comes. This is not an easy thing. This is not at all an easy thing. It's going to be a CPU consuming option. Very high CPU. But what people think, this is a security feature. When you translate and send, the original address is not revealed. So the outsiders will not know the original source from where the traffic is coming. In this way, they think it is secured. That's not true security. True security is, even though you are exposed, no one should be able to touch you. That is real security, not hide and seek. Natting is hiding behind an address. And I don't know how they claim it as security. Because you change the original address to some mapped address and everyone see your mapped address as you, not your original address. They claim it as security. NAT provides security because we are not we are not exposed to the public. We are only seen as the mapped address, not the original address. So we are secured. That's how they advocate for this topic, natting. Natting is one of the security features. If natting is if a security feature, then why attacks are happening? Why then there is Palo Alto, Cisco ASA, FortiGate, Juniper firewalls, antivirus, spyware, malware? Why do we have all these things if NAT can provide security? So NAT is just network address translation. That's how we have to see. It is simply network address translation. Nothing more than that. Why do we do translation? For some reason, I do not want to use my original address. So I translate. Now, what may be the main reason? There are various reasons in networking why we will do netting. One of the most popular reason is we have a private IP address. With a private IP address, the packets are not routable because the public network, the internet, do not know anything about private network. So when I have my private identity locally within my organization, without NATing, I'll be able to reach every device inside the organization. But when I try to use the public network for some services, like browsing, public web servers or taking any cloud service via internet, then the internet needs to know where I am coming from. Internet needs to know my public identity, not the private one. Private one that I have is not a routable network in the public internet domain. So what I was telling so far is within an organization we got private. There is also one of my another friend having private. We all have private. Let's say in my organization I use 10.0.0.1 and my friend also uses 10.0.0.1. We are not conflicting each other. The reason is the edge router that connects to the internet has got a unique identity for both of us called public IP address. Let's say 1.0.0.1, 1.0.0.2. It is not 10, it's 1. So because we got the public identity, whenever A talks to B, the destination address is going to be 1102. When I ping 1102, the packets are routed to the gateway, and this gateway knows where is 1102. Mostly they won't give like this. So let me say 1.0.1 slash 24. So when the destination is 1102, the router here, the ISP router knows that it is here. It pushes the packet here. When it goes here, there is a reverse NAT. There is a reverse NAT. It translates 1102 to 10.0.0.1, and that's how the packet get delivered to B. Likewise, when B replies back, it will reply to this public IP address of mine. Packet will come with the destination address 1011. It gets delivered here, and this has got a reverse NAT saying if any packet comes to 1011, it needs to be delivered to 10.0.0.1. Gets delivered. So even though A and B has got the same IP address, they communicate here because they do not know that we are in same IP address. They know only the other person's public IP address. One zero one one and 1002, they are all public IP address, which is known to the black router. The black router don't have any idea about your 10 network. Even the black may have 10 here, their own local 10, which is not revealed to outside. Let's say this is an ISP. They also may have 10 network. So for the local communication within an autonomous system, everyone uses private address. With that private address, you will not be able to communicate to outside world. For this reason, Whenever you want to go out, you drop your private identity in the gateway on the edge router and pick up your public identity for which NAT is helping. NAT helps to drop your private identity and pick your public identity, and when the return traffic comes, drops the public identity and takes the corresponding private identity. Only because of this today the communication happens in IPv4 network. For these many years, we managed with this. See, every single packet that comes out from every organization is altered by the edge router. They decapsulate and take the original source IP address and they put the mapped IP address. When I say mapped IP address, it's getting mapped to 1011, the public identity. And with that, the packet goes, and when the return traffic comes with the destination 10011, now again the packet will be opened. The destination IP address 10011 is thrown out, and the original address 10001 is the destination address 1011 is thrown out, and the original address 10001 as a destination added there, and again encapsulation, and then sent to A. You see, decapsulation, encapsulation, changing address, this is all process consuming. It is not happening just for one packet. For every packet that goes out and comes in, this needs to be done. This is the reason why I said high CPU utilization. Because every packet needs to be decapsulated, altered, and encapsulated. Going. Again coming, decapsulated, altered, encapsulated, sent in. NATing, network address translation, it changes the layer 3 address. Either source or destination will get changed every time. So this is one of the use case, popular one for NATing. But this is not the only one. NATing is also done sometime between a private address to private address. For example, assume that there is no internet here, middle. You don't have internet. You have purchased your friend's company. B is your friend's company. He sold it to you. Unfortunately, your friend is also using the same network 10 that you already use. Now, how will you make this A and B to communicate? Simple. You need to have one common subnet in between. 192.168.1.1, 192.168.1.2. So you translate all your 10 to 192. According to B, A is identified as 192.168 network. Right? 1.1. According to A, B is identified as 192.168.1.2. Okay, fine. What if I have many computers inside? Then you will have a pool of address and the range of address. Maybe starting from 25 to 50 for this side. Starting from 1 to 24 for this side. So all the devices on the A side identifies the B side device between the number 25 to 50. But originally they are talking to some 10.0.0.1 to 10.0.0.25, which B really do not know. So here you see, for the sake of merging two network that are having same addresses, we use another subnet in between and we translate to it so that we can communicate without conflict. Otherwise, communication is not going to happen if you both are having same name. So NATing is not translating from public to private or private to public, where many people give it as a definition. It's not. NATing is simple. Network means layer 3, address, translation. It need not to be always private to public. It can even be between private to private. Sometimes even between public to public if it is ISP. See, ISP may have 1,000 customers. All 1,000 customers' address is going to be translated to one public address. One public address. And that one public address will be translated while going to another ISP. So, NATing helps to drop the original identity and take another identity for various reasons. It supports various reasons you need it, so NAT supports it. Now, this NAT is of three types. NAT is of three types. One, static NAT, which is one-to-one NAT. Static NAT. Secondly, dynamic NAT, which is one to many. But how many depends on how many addresses you have in the pool. Say, for example, if the pool has got 25 IP address, then only 25 at a time can get translated. The 26th needs to wait someone release the address. Third one is PAT, which is also called as dynamic NAT overloading. As the word says overload, you understand that we are doing some overloading to this second method using port numbers. So they are also called as port address translation. So not only IP address gets translated, even the port number, the layer 4, also gets changed. This is more high CPU consuming feature than the second one and first one. Now, dynamic NAT overloading uses the port number. So it's going to map the original port number to map the port number. It's going to map the source IP address to mapped IP address. By doing so, it can support any number of So we can say, what did I say? One, many to many. Many inside gets translated to many outside. How many depends on how many addresses you have in the pool. That many insiders will be translated. Whereas here, many can get translated to any number of mapped address, any number of destination. There is no restriction, even if you have one address in the pool, just having one address. Even if you don't have a pool, if you got just one address for mapping, you can translate up to 65,000 because you're going to use one single address along with the port number, and port numbers can go up to 65,000. These many translations you can make. Because the port numbers are reserved up to 1,000, so let's say 64,000. With one address, you can go at least, let's say 60,000. 60,000 mappings you can do. Static NAT one-to-one. The big difference between static NAT and the other two NAT is static NAT is bidirectional. Meaning, because you are going to give one inside address, a dedicated one mapped address. For example, Magesh will be called as Magi. So whenever Magesh goes out, he takes the ID Magi to the outsiders. So everyone knows you as Magi. Now, if someone wants to talk from outside to you, they simply talk to Magi. It gets translated to Magish. Because there is a word Magi always mapped to Magish. That never changes. It's one-to-one. Static. Dynamic NAT is not like that. It's not one-to-one. There is no one particular mapped address dedicated for any of the inside address. Sometime first address in the pool is used. For the same computer, next time fifth address in the pool is used. So if someone wants to talk from outside, they do not know what address to talk. Only the communication when it is initiated from inside, the response can come from outside. So no one can initiate traffic from the internet to your server, but when your server initiates traffic, the response comes back. That's unidirectional. The dynamic NAT and dynamic NAT overloading are unidirectional. Static NAT is bidirectional. Do you have any question on what we have seen so far?
Sir, can you just explain the dynamic NAT and the
Okay. Dynamic NAT is anyone in the organization, everyone in your organization has got rights, privilege to go and use the address in the pool. But the address in the pool which is used for mapping, for getting natted, is limited there, only 25. So in your organization, if you have 100 person trying to go online at the same time, only 25, first 25, whoever goes to the pool first, 25 source gets translated. For the 26th source, there is no address in the pool. So there will be a delay until someone releases the address. Did you understand that point?
Yes, sir. But does that mean that those example 25 are these public IP addresses that we define limited?
Yeah. We have in a pool for getting mapped. Those are mapped addresses. It can be public. I told you the NATing is not only between private to public. So I want to use the word instead of private. I want to use the name original address, and instead of public, I want to use mapped address, mapped address, mapped address. The address to which you get mapped. If you want to take it as public, yes, okay, fine. Let's take it as private and public. You got 100 private members trying to use the internet, but because you got only 25 address in the pool, only 25 goes online. Other 75 will be kept in wait, and then when someone in that first 25 releases an address, because they finish communication, the address gets released. The address will be given to this 75 people in a kind of wait and receive. There will be delay. That's what I want to say. Because there is no enough address in the pool for all to go online at the same time. Dynamic net overloading, which is also called as PAT, solves the problem. What is that? You may have one address or 25 address for mapping. Along with the address, an additional unique number called port number given. So you may have the same address, Magesh, Magi A. A is port number. Now for Magesh, Magi is given. Now Rajesh also gets same Magi, but port number is B. Ganesh also gets same mapped address Magi, but port number is C. So when someone responds to Magi B, it goes to Rajesh. When someone responds to Magi A, it comes to Magesh. When someone responds to Magi C, it goes to Ganesh. We use additional entity called port number along with the IP address so that you can have single IP address or few IP address to satisfy many. Many getting translated, not any, one or that's what when I say it may be any number, it can be even one. Because you got port number attached to it, which can go up to 64,000. Because for the port numbers, there are 16 bits. 2 to the power of 16 is 65535, in which 1000 port number 1024 is reserved. All the remaining are unreserved port numbers, which are dynamically used. So when we do the lab, I'll show you these things. What I'm trying to say is dynamic net overloading is faster than dynamic net. Because in dynamic net, when you don't have sufficient address in the pool, there is need for a wait so that someone releases the address for you to use. In dynamic net overloading, which is also called as port address translation patting, the port number is used along with the mapped address so that there is no need for wait here. There is no need for wait because you got a unique identity. Magesh, Rajesh, Ganesh. Both get mapped to the same address Magi, but still For Magesh, it is given Magi A. For Rajesh, it is given Magi B. For Ganesh, it is given Magi C. C is port number, B is port number, A is port number. IP address is same Magi, the mapped address, but the port number attached to it is different. This is what we call as overloading. Just one address you overload with different port number to get a unique identity for each. So there is no need for waiting. But again, as I said, process utilization is a little bit more higher than the previous two. Any question now? Right. The practical side of this we will see in a separate